You will learn about the definition of the cross product. So say we have two vectors u and v. They are both in R3. So vector u and v both have three components. Say u1, u2, u3, and v is a vectors v1, v2, v3. Then the cross product u cross v is another vector, and this vector can be computed as follows. We put the determinant. So this is actually the notation of determinants. You put vector I, j, and k. For the first row, the second row we put vector u, u1, u2, u3. Third row v1, v2, v3. So here we call that vector I is 1, 0, 0. Vector j is 0, 1, 0. And vector k is 0, 0, 1. So they correspond to three vectors. So they are three unit vectors. So they are all of length 1, correspond to the x-axis, y-axis, and z-axis. So now we will compute the determinant. The determinant of a 3 by 3 matrix, so we call this a 3 by 3 matrix. It has 3 rows and 3 columns. And then the determinants can be computed as I, the determinant of this matrix. So when you put vector I here, you delete the first row and the first column. What is left is this matrix, u2, u3, v2, v3. So this is I minus j, and again you delete the first row and the second column. So delete the rows and columns where vector j is on. u1, u3, v1, v3, ij, and we have k. One more. So plus I minus j and then plus k, and again we delete the rows and the column. Case is on, so we delete the first row, the third column. What is left is u1, u2, v1, v2, and this vectors is a vectors u cross v. So let's do a step further. This is a determinant of 2 by 2 matrix. So this is u2 minus u2 times v3 minus v2 times u3. So you multiply element on the main diagonal minus the one on the other diagonal. So these two multiply together minus the other one. I times u2 v3 minus u3 v2 minus j u1 v3 minus u3 v1 plus k times u1 v2 minus u2 v1. So this gives us the cross product of two vectors u and v. Vector I times this number minus vector j times this number minus plus vector k times this number. You can write down in terms of a vector. So the first component is u2 v3 minus u3 v2. Second one and the last one. So this is the cross product of two vectors in R3. Here's an example. Say we have vector u and vector v as follows. Vector u is 0, 4, 4. Vector v is 4 square root of 2, 4, 4. We need to compute u cross v. So what we do is we put I, j, k on the first row, determine another matrix 0, 4, 4. So the three components of u on the second row and v on the last row. 4 square root of 2, 4, 4. So this one gives us vector I times, so delete the rows and the column correspond to I. So we have 4, 4, 4, 4. Minus j. Again, delete these rows and column. We have 0, 4, 4 root 2, 4. 0, 4, 4 root 2, 4. And plus k. Delete the rows and the column correspond to k. We have 0, 4, 4 root 2, 4. This matrix has the rows, first row the same with the second rows. So they have determinant 0. Or one way you can see that is 4 times 4 minus 4 times 4. So the first one is 0 times I. The second one is 0 times 4 minus 4 times 4 root 2. 0 minus 4 times 4 root 2. The last one is k. Again, this is 0 minus 4 times 4 root 2. So we can write down in terms of vectors, so 0, 16 root 2. This is minus, minus, so this gives us plus 16 square root of 2, and we have minus 16 square root of 2. So this is vectors u cross v. And now, what is the length of u cross v? The length of vector u cross v is square root 0 square 16 root 2 square 16 root 2 square. So we have 2 times 16 square times 2. So 16 square root 2 square, we have 2. And we have 2 terms exactly the same, so we have 2 times that. So we have 2 square, 16 square. So we have 2 times 16, which is 32. So this is how we compute the length of vector u cross v. We compute exactly what is vector u cross v.